Hello everyone, in this video we're going to talk about logarithms with base b. So just think, for example, if we had 3 squared is equal to 9, right? We know that. We know 4 cubed is equal to 64. So then we could ask this question, for what value of x does 2 to the x power equal 10? So mathematicians define this x value using a logarithm, and we would write it like this. X is equal to log base 2 of 10. Okay, so that brings us to what is a logarithm? What's the definition of it? Well, we're going to say let b and y be positive real numbers with b not equaling 1. The logarithm of y with base b is denoted as such right here. And we read this as log base b of y, right? So that's like on this one when I read it a second ago, I said log base 2 of 10. That's just kind of the vernacular. That's how you pronounce it and how you read it. Okay, and it says if and only if b to the x power is equal to y, okay? So that brings us to logarithmic form and exponential form. So for logarithmic form, obviously we have the log in there. And so we have log base b of y is equal to x. And so the exponential form would be b to the x is equal to y. So essentially we can go back and forth from exponential form to logarithmic form and vice versa. So one thing to think of, if I want to go from logarithmic form to exponential form, we could think of it as kind of like a little spiral or kind of like a circle here that we're making. So we go b to the x power, right, is equal to y, right? So we can kind of think of it, that's how we would rewrite it like that. Now to go from exponential back to logarithmic, we see our base is b, so just remember that log base b, right? So whatever the base of our exponent is. So here our base is b, our exponent is x. So the base that is b of my exponential form is going to be my base of my log. So log base b. And then our whatever b to the x, whatever our exponent is equal to, b to the x is equal to y. That's what our log is of. So log base b of y and then equals x. So in this video, we're going to rewrite some equations in exponential form and then in logarithmic form. So for the first 4, we're looking at equations that are already in logarithmic form, and we want to rewrite them in exponential form. So for number 1, we have log base 6 of 216. So I know I need to go 6 cubed, and that's equal to 216. So 6 cubed is equal to 216. Okay. For number 2, log base 7. So 7 to the 0 power is equal to 1. Log base 21 of 21 equals 1. So 21 to the first power is equal to 21. And then log base 1/5 of 5 equals -1. So 1/5 to the negative first power would equal 5, right? So we look at those and we say, okay, if I saw that, that is true, right? 6 cubed is 216. 7 to the 0 is 1. Anything to the 0 power is 1. 21 to the first power is just itself 21. And then 1/5 to the negative first, basically that would just kind of flip that over with that negative exponent, right? So we're good there. Okay, in example 2, we're going to rewrite each equation now in logarithmic form. And so now we have 9 squared equals 81. So remember our base here is 9. So we're going to say log base 9. Now it's of whatever our equation was equal to. So 81, and then we're left with our exponent. So log base 9 of 81 is equal to 2. So now we can follow this pattern for the next 3. So for number 2, we can say log base 20 of 0.05 is equal to -1. Number 3, 16 to the 3/4 power equals 8. So we can write it as log base 16 of 8 is equal to 3/4. And then last one, number 4, 15 to the negative second equals 1 over 225. So we can write this as log base 15 of 1/225 is equal to -2, okay? And so that's how we can go from, in example 1, exponential form to logarithmic form, and then example 2, logarithmic form to exponential form. Excuse me, exponential to logarithmic. Now notice this question at the bottom. What do you notice about numbers 2 and 3 from example 1? So that'd be these two right here, 2 and 3 from example 1. Well, notice that for number 2, we have a 0 power in there, and for number 3, we have a power of 1. So if we go down, it says we're introduced to these two special properties of logs, okay? So we have logarithm of 1, so log base b of 1 is equal to 0 because anything to the 0 power is equal to 1. So this is one that we could maybe commit to memory. And then logarithm of b with base b, so log base b of b is equal to 1 because anything to the first power would be itself. Okay, so there's a little bit of a breakdown of logarithms with base b.